This video is going to concentrate on question 7 from 2014 based on pH. Parts A, B, D and E are based mainly on theory that hopefully you'll be able to find yourself in your notes or your textbook. But if anyone has any problems with them, just let me know and I can go through them if that is required. What I am going to concentrate on is part C, calculating pH and the concentration of hydronium ions and OH minus ions. Okay, so the answers for A, B, part 1 of C, D and E are all to the right. So if you don't need to correct your answers, you might pause the video there. Okay, so we've already defined pH. So pH is minus log to the base, the concentration of your H plus ions or your hydronium ion. Okay, so calculate the concentration of H3O plus ion in this solution in moles per liter. So moles per liter is your molarity, so you're just trying to calculate the concentration of your H3O plus. Okay, so from our definition of pH, pH is equal to minus log space 10 H plus or if you want to go with the minus log space 10. Okay, both saying the same thing. Now in this we know the pH, so in our question they say that our pH is 2. So we have a pH of 2. Alright, so our pH is 2 and 2 is going to be equal to minus log . Okay, so to find our concentration, we have to find the inverse log or anti-log of 2. Okay, so our concentration of H3O plus. Okay, to get anti-log or inverse log, just press shift on your calculator and then log, and that will help you to find the anti-log or inverse log. And this is going to be, because this is minus log, this anti-log of minus 2, right, and that gives you an answer of 0.01 molar, and that is your answer for the first part. Okay, explain clearly how this H3O plus ion concentration confirms that nitrous acid is a weak acid. Okay, so we see that the concentration of our solution is 0.2 molar. If this was a strong acid, the concentration of that H3O plus would be the same as that concentration. So if this was a strong acid, our concentration of H3O plus would be also 0.2. If we look at another way of considering what's an acid and what is a base, we can consider that an acid, a strong acid, would completely dissociate in water, whereas a weak acid would only slightly dissociate in water. If our concentration of H3O plus in this solution is very low, if it is 0.1 molar, then this dissociation hasn't completely happened, okay, because we don't have concentration of 0.2 molar of H3O plus. Okay, so this is only about 5% dissociated because we started with 0.2 molar concentration, and our concentration of H3O plus is only 0.01, so only about 5% of that nitrous acid has dissociated into its H3O plus. if we went as far and calculated the acid dissociation constant, it comes out to be 5 by 10 to the minus 4, which is also consistent with a weak acid. Okay, I wouldn't really be expecting you to know that maybe. Might be not the first thing you might think of in an exam, but definitely the first two should be, you should know. Okay. The next part of our question is what concentration of nitric acid would have the same H3O plus ion concentration? Nitric acid is a strong acid, so as we mentioned earlier, the concentration of your H3O plus ions will be the same as your concentration of the solution. Okay, so this says what concentration of nitric acid would have the same H3O plus ion concentration. If our concentration of H3O plus is this 0.01 molar figure, well then concentration of nitric acid that would have the same concentration of H3O plus ions in it would also be 0.01 molar. Okay, in a strong acid, the concentration of your H3O plus ions, or your H plus ions, is the same as the concentration of the solution itself. And the last part of our question is calculate the OH minus ion concentration in both of these acidic solutions. Okay, so we're just trying to find our concentration of OH minus. And we already know the pH. Our pH is 2. Okay. Now, we know that if we add pH and pOH, that should equal to 14. So, our pH we know that pH is 2. So, our pOH then, of course, is going to be equal to 12. Now, similar to what we did earlier to find our concentration of our hydronium ions up here, we're going to find the antilog. Okay, so if we go that our concentration of OH minus is going to be antilog minus 12. Okay, this minus is just because if we were finding our pOH, it is minus log to the base 10 OH minus. Okay, so that's just the where the minus is coming from. Okay, and 1 by 10 to the minus 12 molar anyway is our final answer there. Okay, so I hope that clears up part C. If anyone has any questions about any of the theory parts, just let me know. The answers are over here to the side, so if you need to pause and have a look at them, do that.